So we're going to talk about the primary trig functions, okay, the original ones. So number one, sketch a curve of f of theta equals sine theta, okay, from 0 to 2 pi. So for sine, the max is 1 and the minimum is -1. Okay, so let's put the max here as 1. Let's put the minimum as -1. And the amplitude is 1 because we are going to go up 1 unit from this equation of axis, right? 1 unit. Okay. The period is 2 pi. It takes 2 pi to do 1 full rotation. Okay. There's no asymptotes in sine. The domain is XER because we go to the left forever. It continues to oscillate, and this is periodic. And we go to the right forever. Again, it continues to oscillate, and this is periodic. Okay, so the range is going to be a mixture of the max and the min. So the range is going to be from -1 to 1, and it includes those. So you can write it like this, or you can write it YER such that y is between -1 and 1. Okay, number 2, sketch the curve f of theta equals cos theta. Okay, on 0 to 2 pi. So again, the max is 1 and the minimum is -1. So let's put the max here and the min here. And then the cos curve starts at a maximum, goes down to the equation of axis, minimum, back up to the equation of axis, and back up to a maximum. Okay, the amplitude, which is the equation of axis to any of the humps, we call them humps. Okay, it's 1. The period is 2 pi. That's 1 full rotation of cos. There's no asymptotes. And the domain is XER because there's technically arrows on both ends. And this is periodic, so it continuously repeats. And the range is -1 to 1. Okay, sketch the curve of f theta equals tan theta on 0 to 2 pi. Okay, so tan theta goes through 0, 0, and there is a vertical asymptote at x equals pi by 2. Okay, so vertical asymptote at x equals pi by 2. And then this goes like this. And it approaches the vertical asymptote, but never hits it. Okay, then it continues approaching -infinity. Well, it approaches x equals -2 from the right. And then this goes like this. Okay, and then we go through pi. So the difference in these two numbers, 3 pi by 2 and pi by 2, is going to be our actual period because this is 1 rotation of tan. And this is 2 pi by 2, which is just pi. Okay, so the period here is pi. And then this goes from here to here. Okay, so there's no max because it approaches infinity. Okay, so let's go approaches infinity. There's no min, it approaches -infinity. There's no amplitude because it's not sinusoidal like this. But it's still periodic. The period is pi. The asymptotes occur, if you think about the asymptotes, they occur starting at pi by 2. There's going to be an asymptote 1 period to the left and 1 period to the right. And then another period to the right and another period to the left. So how we denote that is plus or minus the period, which is pi, and then n, like n number of times. So infinitely to the right and then infinitely to the left, pi units away from one another. Okay, the domain is going to be XER such that, here's the thing, tan is never going to be defined at a vertical asymptote. So x is not going to equal pi by 2 plus or minus pi n. that is a those are the vertical asymptotes. So those are the restrictions on the domain. Okay, and the range, we already talked about the max and the min, negative infinity to infinity. So conclusions, where are the vertical asymptotes of the tangent graph? So like tangent graph is just tan theta, obviously, located on 0 to 2 pi. Okay, so if we remember the tan graph, go like this, and then that's one full, like that's 0 to 2 pi. So these are located at pi by 2 and 3 pi by 2. Okay, why are they found at these locations? So tan theta equals sine theta over cos theta. Okay, so at pi by 2, if you think about tan theta, what is sine at pi by 2? Okay, so sine of pi by 2 is here, it's 1. But cos of pi by 2 is 0. So there's going to be a vertical asymptote because VA, because the denominator of tan, which is like sine theta over cos theta, equals 0. So it's undefined at this point. Okay. How does the period of tangent function compare with the period of the, it's supposed to be sine and cosine functions? So sine and cosine functions have a period of 2 pi. Tan has a period of pi. So it's half of the sine cosine period. Okay, and why are there no max or min values of the tangent function? Okay, it approaches the vertical asymptote. And approaches infinity or negative infinity.